Good morning, student. In the previous lecture, we saw the modules and a port in Verilog HTL. Now, in this lecture, we will learn the two important concept in Verilog HTL, which are system task and compiler directivity. So, what is the system task and what is the compiler directivities? So, first is system task. So, system task is nothing but a specific tasks that assigned by a Verilog HDL. So to perform that particular or to specific task, some important instructions are there in Verilog HDL. So what are these different tasks that we will see in this lecture? Okay, the Verilog provides standard system tasks for certain operations. So to perform a particular operation, to perform particular operation or to perform a particular function, there are some system tasks. So that system tasks perform a particular operation. Okay, so all system tasks appear in the form of dollar and keyword. So this is the syntax of defining or declaring the any system task. The first is a dollar sign, and after that dollar sign you can define the name of operation or name of function. So operations such as a displaying on the screen, suppose there is some variable, so the value of that variable is a display on screen. So how the value of that variable is a display on your screen? So so this is the system task to display the value of variable on a screen. So for displaying, so here we write dollar, dollar sign, and after the dollar sign we write display. That means dollar display. So whenever dollar display this keyword or these instructions come, then compiler will understand that the value of this variable we have to display on the screen. So there are some other tasks like displaying information on screen, monitoring the values, stopping and finishing are done by a system task. So these are the four system tasks that included in a Verilog HDL. First is display on the screen. Next, second is monitoring the value of net, stopping and finishing are done by a system task. So these are the four functions that are done by a system task in Verilog HDL. Okay. So first is displaying information. So dollar display. So dollar display is the main system task for displaying the value of variable or string or expressions. So dollar display, whenever we use a dollar display, that means the compiler will understand that the value of some variable, so or the string or the expression have to be displayed on a screen. Okay, so this is one of the most useful task in Verilog. So as a display is a perform a is a look like or it is the same as a printf in C language. So whenever we give a printf instruction in C language, so printf means whatever written in a double quote is a is a display on a screen. Whatever write in a double quote is a display on our screen. So similarly, in a Verilog, instead of printf, we use dollar display. In C language, we use a printf to display the particular information on a screen. So in Verilog, we use dollar display instead of printf, but the function of dollar display and printf is similar. So how we write dollar display P1, comma P2, comma P3 up to Pn. So P1, P2, P3 can be the quoted string variable or expressions. So all these P1, P2, P3 are any, either it is variables, either it is expression or it is a string of character. It may be any information that will be displayed on our screen. The format of dollar display is very similar to printf in C. So the format and function of dollar display is similar to printf. Okay, so the dollar display insert a new line at the end of the string by default. So at the end of string we put a we put a new line. That means new line means what? The next character is a display on a next line. The new character is a display on a next line. When if we not include the new line character, then all the string are display on a single line. So but whenever we want to display the next character or next statement on a next line, we put a new line character. Okay, so here are the some examples. So $display hello verilog word. So whenever this line come, $display in double quote hello verilog word, the hello verilog word, this statement will display on your screen. Okay, so here are some special format. So whenever we use a %d or %d, that means a display variable in decimal format. D stands for decimal. So whenever we give a percent d, that means a variable is a display in decimal format. When we give $b, that means the variable or number will display in a binary format. Dollar sorry percent s, when percent d, when we write percent d, then the variable display in decimal format. When we write percent b, then the variable is a display in binary format. And when there is a percent s, s stands for string, so it is used for a character, it is used for a character. So all the character that are present in a double quote is a display on the screen. Percent h used for hexadecimal number. So when we write a percent h, then the variable is a display in a hexadecimal value. The next is a percent c. C stands for ASCII character. C stands for ASCII character. So whenever we write percent c, the character or the ASCII character will display on our screen. Percent %m. Percent %m means display hierarchical name or argument required. Percent %v. Percent %v represent the display strength. Percent %o. Display variable in octal format. O stands for octal. So whenever we write percent %o, the number will display in a octal format. Now the percent %t. Percent %t is the current time of format. Current time of format. That means time is a display on our screen. Percent e represent a real number, is a real number. That means 10 e 3e10, that means 10 raised to 3, that means 10 raised to 3. So whenever we write percent e, the number will display in a real format. Percent f is a float number, that means it is the fractional number. So whenever we write a percent f, the number of the value will display in a float format, that means in a fractional format 2.13. Or percent g is stands for display real number in scientific or decimal, whichever is shorter. So the number is displayed in scientific format or in a decimal format whenever it is convenient to write. So these are the different format. So basically dollar display is a is used to display the any information on our screen. So this is the first system task. Okay, here dollar display hello verilog world. So whenever dollar display come, the compiler display this message on our screen. Here dollar display s time, that means s time is display on our screen. Okay, the next is monitoring information. The next task is monitoring information. So Verilog provide a mechanism to monitor a signal when its value changes. So monitoring information, this task include, or the function of this task is to monitor the value of particular variable. To monitor the value of particular variable, and it is written in this form: dollar monitor p1 p2 p3 up to pn. That means the value of p1, either it may be variable, string, or expression, whatever may be the value of p1 p2 p3 is continuously monitored by a compiler, because it perform a system task dollar monitor. Okay, the parameter p1 p2 Up to pn can be variable, signal name, quoted string. A format is similar to the dollar display, but the function is to monitor the value of that particular parameter or the value of that particular variable. So dollar monitor continuously monitor the value of the variable or signal specified in the parameter list. So dollar monitor continuously monitor the value of particular variable that will inserted in this string. So here are p1, p2, p3 up to p1 variable. So system task monitor is a continuously monitor the value of this variable. Okay. So you continuously so you continuously monitor the value of a variable or string in the parameter list. So in parameter list there are many parameters starting from p1 to p1. So all the parameters that are listed in this format, that are listed in this bracket, so all the value of these parameter are monitored by a system task. Okay. So here, so only one monitoring list can be active at a time. If there are more than one S monitor statement in your simulation, the last S monitor statement will be active statement. The early S monitor statement will be overridden. That means you can write many S monitor tasks in a single program, but last S monitor task is activated, and the early as dollar monitor statement will be overridden. That means, suppose there are one program, so within that program you can write a multiple dollar monitor statement. You can write a multiple dollar monitor statement. Then the last statement of program is activated. So the early statement will be overridden to last. So that means, suppose there is one program, so in that program you write $5 monitor statement, $5 monitor statement. Then compiler execute $5th monitor statement. Compiler execute $5th monitor statement. It cannot be used first four statement, because the first four statement is overridden. That means it is overwritten. So it perform only last active statement. Okay. Now the system task monitor have two types: monitor on and monitor off. When you write $monitor on, that means the compiler start monitoring the particular variable, and when you write $monitor off, then compiler stop monitoring that variable. So there are two monitor tasks: $monitor on and $monitor off. The $monitor on means compiler start monitoring that particular variable or particular parameter, and when you write $monitor off, then compiler stop monitoring that variable. Okay. So these are the monitor $monitor. Now the next is stop and finishing system task. So $stop. The dollar stop indicate that the simulation is stop. The simulation is stop. And finish. So $finish system task finish the simulation. It stop the simulation and it finish the simulation. The task $stop is provided to stop during a simulation. So when the simulation is done, so within that simulation, whenever $stop the system task come, then the compiler stop the simulation, but it cannot terminate. It stop the simulation for particular time. Okay. And when we write $finish, then it finish the simulation. The the task $stop is provided to stop during a simulation. So we can write $stop. So the stop task put the simulation in an interactive mode. So designer can then debug the design from the interactive mode. The stop task is used whenever designer want to suspend the simulation and examine the value of signal in the design. So by using stop system task, the user stop the stimulation whenever he want. Okay. Now the next is a finish task, terminate the stimulation. Terminate the stimulation, that means it finish, it complete the stimulation. Okay. So these are the four system tasks. First is mo- monitor, next sorry, first is display, second is monitor, third is stop, and fourth is finish. Display the information, monitor the information, stop the simulation, and finish the simulation. So all the system tasks is indicated by a dollar sign. All the system tasks indicated by the dollar sign. So there are four system tasks in Verilog HDL. First is display the information, second is monitor the information, third is stop the simulation, and fourth is finish the simulation. So and all the system tasks are declared or defined by a dollar sign. Okay. Now the next is compiler directivity. What are the compiler directivities? Compiler directivities. So compiler directivity means what? In C language, you write at the beginning of program, you write hash include. So these are the compiler directivities. So similarly, in Verilog language, there are some other compiler directivities. The compiler directivities are provided in Verilog. All compiler directivity are defined by using the keyword. So particular directivity are defined by their keywords. So first compiler directivity is defined. First compiler directivity is defined. So the define, and it is defined by the keyword define. So it is declared by a keyword define. The defined compiler directivity is used to define the text in Verilog. The Verilog compiler substitute the text of the macro whenever it encounters. So this is the example of a defined directivity. So the define a text macro that define default word size. So use as the word size in the code. So define word size 32. That means whenever word size come, then it define the size of that word is 32. That means the word size of that word is 32. That is defined by a define directivity. Suppose you take a variable y. So if you write define y, and after the y you write 16, define y 16, that means the size of that y is a 16. The size of that y is a 16. So define directivity define the size of that particular variable or that particular parameter. Okay. So define define and alias. A stop will be substituted whenever s appear. Define s stop. Okay. So you can stop the whenever you stop to gain this size, you can simply write dollar stop. Okay. Then the define. So when we define size, that means whenever this word come, the compiler take the size of that word which is defined by define directivity. But whenever we give a define dollar stop system task, then the compiler stop gaining this size. That means if you give, suppose you define y 16, that means the size of y is 16. So whenever y character come, the compiler take the size of y 16. But when you give define y dollar stop, that means compiler stop taking the value of y as a 16. That means it cannot be take the value of size of y as a 16. Okay. So here define the size, and here it stop to define that size. Okay. Define. Now the next directivity is include. The include directivity allow you to include entire content of Verilog source file in the another Verilog file during compilation. So include directivity is same as hash include in a C language. So whenever include directivity come, the include directivity is used to include the content of file into another Verilog file. The include directivity is used to include the entire content of Verilog source file into another Verilog file during the compilation. So suppose there are two files, file A and file B. So in file A there are some data. So whenever include directivity come, whenever we write a include directivity, then the content in file A can be automatically included in a file B. Okay, so here, here include the file header.v which contain declaration in the main Verilog file design v. So here there are two files, include header file and include, there are two files, header.v file and design.v file. So whenever include header.v, that means the content present in header.v file can be added in a design.v file. Okay, so there are two files, header v files and design v files. So when include directivity come, then the content present in or the data present in a header.v file can be automatically stored in a design.v file, because here we use a include directivity. So include directivity is used to add, to include the content or to include the data from one file to other file. So in this way compiler directivities work. So in Verilog HDL there are two compiler directivity. First is a define directivity and second is include directivity. The define directivity define the size of particular word, and include directivity include the content in one file to another file. So define directivity define the size of word, and when we give us stop system task, then it stop defining that size, it stop defining that size. Okay, and include directivity is used to include the content in one file into another file. So these are the compiler directivity. So there are four system tasks: display information, monitor information, stop simulation, and finish simulations. So these are four system tasks, and all the four system tasks are declared by a dollar sign. And there are two compiler directivity, define directivity and include directivity. So these are two most important concept in Verilog HDL. Okay, now we will stop here. In next lecture we will continue with logical operator. Now we will stop here.